So now let's do the motion coming back down. The Coriolis acceleration coming back down, and this is down. I'm not going to put the subscript or superscript on AC. This is equal to -2 omega cross. This time it's coming down, so it's coming down everywhere along that path. Again, to lowest order. We're not really including the omega correction for the velocity in the x direction. It's small. Remember, omega on Earth, 10 to the -5. So this damps out all that. But at the end of the day, we're carrying the first order to get the deflection. So this is minus gt coming down, k hat. And this will come out to be -2 omega naught sine theta. We get here minus of a minus, and then this is omega cross k again, is in the positive x direction, the way I've drawn the Earth. So this will be minus, and I just go ahead and put a plus here once and for all, gt I hat. So that part works out good. So going again, dropping the vectorial property of that because we know it's all just in that direction. I integrate once. Now let me write this down. So x double dot is equal to 2 omega naught sine theta gt, integrate once. Here's where you get into trouble if you don't do this right, okay? Now, this went up. This is highly exaggerated. It came back down. I'm going to... This is my new x0 right here at the top of the path, okay? So I just don't feel like carrying that constant around. So I just did this one, and I'm going to reset the origin right here at 0, starting from the downward trajectory at the apex. I think that's the word. I don't know. So I integrate this once, and I get x dot is equal to 2 omega naught sine theta gt squared over 2. That part works. Here's what you miss if you rush through this. You got a constant here, v naught, evaluated at time t equals 0. Because when you have you're starting at t equals 0 from up here, so you drop it. That thing has a velocity up there. In fact, I can go back and find that velocity because it's the velocity in the x direction left over from when it was up and tilting to come back down. If it were Coriolis free environment, it would go up, down, and I would have no transverse velocity. But this comes up, deflects, has a component this way. I need that velocity. This is my new t equals 0. You can do this all in one. It's just ridiculously more complicated. So I split this up. So I go back and I find what v naught was. So v naught at 0 is the velocity up here, which was at t. I need v naught x at t to use. You do this all the time in general physics. You just reset everything. I need this from the upward part. Well, I go back and I find it, and it is this here. And I'll rewrite that again so you guys don't have to scroll back and forth on the movie. So this is v naught. Here's what I have. So go back here. So v naught evaluated at t, x will be my new v naught x on the down path. And I plug everything in there, and I'll have, in fact, let's integrate it and see. Oh, here it is, right there. So when t is equal to 0, that vanishes. This term vanishes right here. This term, I'm circling it. That term vanishes. So I have to have these two match up. And I know it's moving, so this has to have a value, and that value is this. So I'm -2 omega naught. Oh, it's 2 omega naught from back there. 2 omega naught sine. I got to go back and look. Actually, is it plus or minus back there? It's minus. Okay. -2 omega naught. I said I'd write it down again. I didn't. -2 omega naught sine theta. And then we evaluate that at g t squared minus g t squared over 2. This simplifies nicely. Let's check those coefficients one more time. There's this coefficient of 1 here and a coefficient of 1/2 there, which is this. So this is -2 omega naught sine theta. Then I have g t squared. And already forgot what all this is. This is G, just T squared over 2. And this will come out to be minus 2 omega naught sine theta G over 2. Remember what T is. It's 2Z naught over G. So I'm left with, at the end, minus 2 omega naught sine theta times Z naught. That's the term you got to have. And now you can get what X is by integrating this again. Currently, let's be redundant and rewrite everything we know. This is now 2 omega naught sine theta G, T squared over 2. That's what I have from the first part of the calculation. And here's what I have from my boundary condition. 2 omega naught sine theta, Z naught. And now I'm going to integrate this. When I integrate this, I will get 2 omega naught sine theta, G, T cubed over 6. That works pretty well. And now this is a constant that I integrate to get this. And of course, to be consistent, I have an x0 here. But if I start there, look at the screen. If I start there, this is my new, I call it, x equals 0. So I'm just measuring this. How far that deflection is at the bottom. That's equal to 0, T equals 0. That's got a T and that's got a T. The first two terms do. So that's 0. And now I plug in what I have for the time it takes to come back down. So the deflection will be equal to, this is X, 2 omega naught sine theta G, and then this will be, oh, let's see. Make sure I got that right. Go. It's 2 omega naught sine theta G T cubed. Let's put the intermediate step, T cubed over 6. Yep. Minus 2 omega naught sine theta Z naught T. The rest of this is just, let's see, that's a 1/3. Debating. Let's put out omega sine theta to kind of make this a little more simple to read. This is omega naught sine theta. 2 over 6 is 1/3. So I got the sine theta. Then I have G 2 Z naught cubed over G. All that's to the power 1/2. Then I have still, let's see, I got the 1/3 out. That's still a 2 minus 2. Looks like it's a mismatch, minus 2. Then I have Z naught, and here's what I'm going to have, 2 Z naught. Now notice that's just to the power 1/2 this time, G to the power 1/2. So this works out pretty nicely, because what I'll have now is omega naught sine theta, 1/3. This guy is 2 Z naught cubed over G, 1/2. And if you look at this thing, I got a 2 Z naught here and I got a 2 Z naught there. So if I bring that in, that's squared under the 1/2 sign. So that's minus 2. Oh, there's no 2. On the outside is 2 Z naught now. This goes in here. Cubed. The G is still to the power 1/2. And this is then omega naught sine theta, 1/3 minus 1, which is minus 2/3. All that business, 2 Z naught cubed over G, power 1/2. The rest of this, of course, is now minus 2/3 omega naught sine theta. How about them apples? 2 Z naught cubed G. So that's minus 2 X drop. So X deflection is equal to minus 2 X drop minus another 2 X drop, which is minus 4. You can't believe the satisfaction I'm taking from that. X drop. And notice it's in the opposite direction. So it's actually west. Yeah. Just dropping it, you deflect east, but if you throw it up and down, it deflects west.